Hey everyone, we're going to do a review on simplifying square roots. And these first four here in the directions, it says to use absolute value when necessary. So since we're doing square roots, sometimes we do need to use absolute value symbols if we can take the square root. So for instance, our first one, square root of 20, x to the fourth power. I'm going to rewrite that as the square root of 4 times 5, because 4 is a perfect square. And then x to the fourth is a perfect square as well, so I'll leave that just as is. Now, I know that 4 is a perfect square, and again, I said x to the fourth is a perfect square, so when we do that, we get 2, and then the square root of x to the fourth is x squared. Since it's x to the second power now, we do not need absolute value because it would become positive when it would be squared. Left is our root 5, and that is our answer. Number 2, let's rewrite that. 162 is 81 times 2. And then x to the 11th, I'm going to write that as a perfect square, which is x to the 10th, and then x to the first. Remember, we add our exponents if we're multiplying the same base. Now our perfect squares, again, are 81, and then our x to the 10th. Square root of 81 is 9. Square root of x to the 10th is x to the 5th power. Now, because it's a 5, we do need absolute value there because that's an odd exponent. And then we'll write what's left in our radicand. So it's going to be square root of 2 and then x. 3 has a coefficient of -4, so we want to be sure that we do make sure we multiply by a -4 at the end. We're going to break 98 down to 49 times 2. And then we have that y there. 49 is a perfect square. So the square root of 49 is 7. So I have a -4 times 7, which is -28. And then we cannot take the square root of 2 or y, so we just have 2y in our radicand. There we go. And then the last one here, number 4, we have the quantity of x minus 4 raised to the 7th power. So I want to rewrite that again so that it is a perfect square. So I'll do x minus 4 raised to the 6th power. And then x minus 4, oops, wrong thing there. Let's see if I can undo that. There we go. And then x minus 4 to the 1st power. So this x minus 4 to the 6th is a perfect square. So when I take the square root of that, I get x minus 4 to the 3rd power. Now, 3rd power, that is odd, and it was a square root. So we need those absolute value symbols. And what's left is that x minus 4. And you don't need to put that 1 in there. Visible 1, you can just write x minus 4 and your radicand. So moving on now to numbers 5 through 8. These do not need absolute value. We're performing operations and we're going to assume that all the variables here are positive. Now, number 5, we did a little bit of this review when we did the complex numbers, imaginary numbers. And when we did that, we had to make sure we simplify the radicals first before we multiply. Because there aren't any imaginary numbers here, we can combine our radicands by multiplying right away if we wanted to. So this first one here, I'm going to multiply that 8 times 5 and I get 40. So those are our coefficients. And then the square root of, I have 6x and then 2x to the 5th. I'm going to rewrite the 6 so it's 3 times 2. And the reason I'm doing that is I have a 2 in the other radicand. And then x and x to the 5th, add those exponents, you get x to the 6th power. So our perfect squares would be this 2 times 2 or 4, and then x to the 6th. So we will take the square root of those. We get 40 times 2, which is 80. And then square root of x to the 6th is x to the 3rd. And then I have root 3. Again, you do not need absolute value for 5 through 8 because we're assuming the variables are positive. For 6, I actually like to look at this as one fraction and simplify that. So I get 5, my coefficient, and then 15 over 10. I can simplify that because they're both in the same radical square root. So divide by 5, I get 3 here. Divide root 10, and we're going to get 2. All right, so again, because it's square root, we can simplify those. We could not do anything with that 5 because that is not inside a radical. We have to get rid of that radical in the denominator, so I'll multiply by root 2 over root 2. And that leaves me with 5 root 6 over the square root of 4, which is actually 2. All right, 7, we're going to distribute. Again, we're going to multiply our coefficients together and then multiply what's in our radicands. So 4 times 2 is 8. And then I get root 3 times root 12, which is actually root 36, or 6. So I can go ahead and multiply that. 8 times 6 is 48. Okay, and don't forget, we have to distribute still to our second part here. So we're going to get plus, it's going to be 4 root 18. And 18, you can think of that as 9 times 2. Square root of 9 is 3. So we have a 4 times 3. And then our root 2. So it's going to be 48 plus 12 root 2. You do not need to factor out a GCF here. You can leave it just as is, and you cannot combine like terms because they are not both root 2's. And our last one, we have an expression in the denominator, 4 minus root 2. To get rid of our radical in the denominator here, remember we have to multiply by the conjugate. It's that difference of squares, a minus b, a plus b is a squared minus b squared. So we're going to multiply by 4 plus root 2. All right, and I always like doing my denominator first. So I'm going to do 4 squared minus root 2 squared. So I get 16 minus 2, which is 14. And then I'll check to see, does it simplify with root 3? No. So I'm going to just go ahead and distribute that numerator, which will be 4 root 3 plus root 6. Can't simplify any of those. So then we don't forget about our denominator, which is 14. So hopefully you remember how to do the roots a little bit and do well on the practice worksheet. We're going to be learning more about square roots, cube roots, fourth roots in this next chapter. All right, take care.